بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 5. Today we want to learn how to subtract mixed numbers. See with me now this video.
We get it. You don't really want your kids watching videos, but it can have...
Hi, I'm Rob. Welcome to Math Antics. In our previous lesson, we learned how to add mixed numbers. And in this lesson, we're going to learn how to subtract them. Subtraction is always a little trickier than addition because subtraction does not have the commutative property. That means that the order of the numbers you're subtracting matters, and you can't switch it like you can with addition. Subtraction is also tricky because if you try subtracting a number from a smaller number, like 1 minus 5, you get a negative answer. Fortunately, we're not going to cover any problems that give negative answers in this video. But as you'll see in a few minutes, there are cases where it seems like you need to subtract a bigger number from a smaller one at first. All of this means that subtracting mixed numbers can be quite a bit more complicated than adding them. But don't worry, we'll take it one step at a time. And it'll help a lot if you make sure that you have a good understanding of topics like adding mixed numbers, subtracting fractions, order of operations, and multi-digit subtraction, because this lesson builds on all of those concepts. Okay, to see why subtracting mixed numbers is trickier than adding them, let's have a look at two problems side by side. 5 plus 2 1/3 and 5 minus 2 1/3. We learned how to do problems like the first one in the previous video about adding mixed numbers. Since 2 1/3 just means 2 plus 1/3, we learned that we could rewrite the problem like this and simply add up the whole number parts to get the whole number part of the answer. 5 plus 2 is 7, so the answer is 7 1/3. But if we try to do the same thing with subtraction, we're going to get the wrong answer. If we rewrite 2 1/3 as 2 plus 1/3, it looks like we could just subtract the whole numbers. 5 minus 2 is 3, which leaves 3 plus 1/3, or 3 1/3, as the answer. But it turns out that's not correct. Oops. So what did we do wrong? Well, when we subtract a mixed number, we need to subtract the entire mixed number. We need to subtract the whole number part, and we need to subtract the fraction part. But we didn't subtract the 1/3, we added it. That's because when we rewrote the mixed number as a sum of a whole number and a fraction, we forgot, or we didn't realize, that they form a group. We just put the 2 plus 1/3 right after the minus sign, and it made it look like we should subtract the 2 and add the 1/3. But we actually should have subtracted both of them. One way to avoid that mistake is to use parentheses around the mixed number you're subtracting so you remember that its parts form a group, and you need to apply the minus sign to the whole group. And you can only get rid of the parentheses after you apply or distribute the subtraction to each member of the group, like this, minus 2 minus 1/3. Now that we have the problem written correctly, we'll get the right answer if we do these math operations. Going from left to right, we have 5 minus 2, which is 3. But then for the last step, we need to subtract 1/3 from 3. That might seem hard to do unless you remember what we learned about whole fractions in the last video. When adding mixed numbers, sometimes we'd get an answer like this, 2 3/3. But since 3/3 is what I call a whole fraction, its value is just 1. And we learned that we could simplify an answer like that. 2 3/3 is 2 plus 1, which is 3. Well, how about if we just do that same process in reverse? Instead of simplifying, let's unsimplify. We're trying to take 1/3 away from 3, right? So let's rewrite 3 as 2 plus 1, and then let's rewrite 2 plus 1 as 2 plus 3/3. Does the problem look easier to do now? We converted part of the whole number into the whole fraction, 3/3, and we already know how to subtract fractions. 3/3 minus 1/3 is 2/3. So that means our final answer is 2 2/3. So as you can see, subtracting mixed numbers can be a little complicated, but not all problems are that hard. Some are pretty easy, like this one, 6 4/5 minus 1 3/5. We still need to remember that the mixed numbers form groups, so we have to subtract both parts. But that's where the stacked format that we learned about in the last video can really help us out. Since the order of a subtraction problem is important, we need to be sure to put the mixed number that we're starting with on top, and the mixed number that we're taking away on the bottom. And doing that helps us remember that both parts of a mixed number are being subtracted, even if we don't put parentheses around them to remind us. That's because we'll subtract the parts column by column, just like we would in multi-digit subtraction. We'll subtract the fraction on the bottom from the fraction on the top, and then we'll subtract the whole number on the bottom from the whole number on the top. 4/5 minus 3/5 is 1/5, and 6 minus 1 is 5. So the answer is just 5 1/5. See, that really was easy, and that's why I recommend using stack form whenever you can for subtracting mixed numbers. It'll help you remember that both parts of a mixed number are being subtracted without having to worry about groups or parentheses. But even though the stacked form is a great way to keep from getting confused about groups, it doesn't make every problem quite that simple. For example, let's try the problem 5 1/7 minus 2 3/7, and let's use stack form again. We're starting out with 5 1/7, so it goes on top, and 2 3/7 goes on the bottom. But when we try to subtract the fractions column, you'll see that we have a little problem. 1/7 is less than 3/7, so we can't subtract it without getting a negative number, which we'd really like to avoid. So what do we do now? Well, do you remember what you do in multi-digit subtraction when you have to subtract a bigger digit from a smaller one? Yep, you borrow or regroup from the column to the left. And we can do something really similar to that with mixed numbers. We can make the fraction part of a mixed number bigger by borrowing from the whole number part. In the video about adding mixed numbers, we learned that a mixed number with a fraction part that's improper is bad form, because you can simplify out a whole fraction and then add it to the whole number part. Well, we can do that process in reverse also. We can subtract out 1 as a whole fraction from the whole number part and add it to the fraction part to get an improper fraction. And even though that's considered bad form, it's okay because it's not our final answer. And it helps us subtract the fraction column without getting a negative fraction. In this example, we do that by changing the whole number part, 5, into 4 plus 1, and then changing 4 plus 1 into 4 plus 7 over 7. And finally, we can combine that 7 over 7 with the 1 over 7 to get 8 over 7. Now the fraction on top is big enough to subtract 3 over 7 from. 8 over 7 minus 3 over 7 is 5 over 7. And then we just need to subtract the whole number parts. The top whole number used to be 5, but we borrowed from it, so now it's 4. 4 minus 2 equals 2, so our answer is 2 5/7. Let's try another example to make sure you've got it, and let's make it a story problem this time. Suppose there's this guy who's a builder named Rob, and suppose he needs to fix something by subtracting the mixed number 1 5/8 from 6 1/8. Can he fix it? Yes, I can. Well, at least with the help of my trusty cat, Richard. Where did that rascal run off to? Richard? Richard? Oh, well. The first thing we need to do is put these in stacked form, with the number I'm taking away on the bottom. Then I need to subtract the fractions. But I notice that the fraction on top is less than the fraction on the bottom. So I need to make the fraction on top bigger by borrowing from the whole number part. I can replace the 6 with 5 plus 1, and I can replace 5 plus 1 with 5 plus 8 over 8 to get the whole fraction I need to add to the top fraction. 8 over 8 plus 1 over 8 is 9 over 8. So now I can subtract the fraction column because the fraction on top is bigger. 9 over 8 minus 5 over 8 is 4 over 8. And then I can subtract the whole numbers. 5 minus 1 is 4, so the answer is 4 4/8. Does that look right to you, Richard? You're right. 4/8 can simplify to 1/2. So my final answer is 4 1/2. Thanks for your help, Richard. Good job, Rob, the builder. So now you know how to subtract mixed numbers. Some problems will be easy, like our second example, where you can just subtract the fraction parts and the whole number parts. But in other problems, you may need to borrow or regroup using that unsimplifying procedure. And remember that the stacked form is a great way to keep everything straight. Of course, you may also need to solve problems where the mixed numbers have unlike fractions, and you'll need to change them into like fractions before you can subtract. But that works the same way as you saw in the last video, so you already know how to handle that. I know I'm always saying it, but that's because it's true. The way to really learn math is to practice by doing some problems on your own. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Today, we want to learn how to subtract mixed numbers. As you see here, we have 6 and 4 over 3 minus 4 and 2 over 3. Here we have mixed number and here we have mixed number, and the operation here will be what? Will be minus. What's the meaning of mixed number? Mixed number include whole number and fraction. Whole number and fraction. And as you see here, the two fractions here has the same denominator. It means I have like fraction. I have like fractions. So I can do subtract directly here. Directly. In the second example here we have 8 and 12 over 7 minus 6 and 5 over 3. As you see here we have 7, here we have 3. So here I have unlike fractions, so I cannot do directly the subtraction. So must to do or to make the same denominators, then to change from unlike fractions to like fractions, then we can do the minus. Now see with me this video.
Welcome to the International British Online School, the world's leading British online secondary school. We believe that all...
Subtracting mixed numbers, part 2. In my first video on subtracting mixed numbers, I designed the problems to work out easily. But you're also going to get questions that don't go quite so simply. This won't be a problem for you though. You already have the skills you need for success. And they are to change a mixed number to an improper fraction, to change an improper fraction to a mixed number, and to simplify a fraction. Let's do one. Remember, first we need a common denominator. Our common denominator will be 6. To turn 3 into 6, we multiply by 2. So up top, we get 4. And now we've got a problem. In the numerators, we've got 4 here, and we have to subtract 5. We can't do it like we did before. This time, we can't separate the fractions from the wholes. Instead, we do this subtraction in one shot. If we change our mixed numbers with that common denominator into improper fractions, we will solve it easily. 2 and 4/6. So 2 groups of 6 is 12, plus the 4 from the numerator makes 16 over our denominator of 6. And here we've got 1 group of 6 plus our numerator of 5. That's 11 over 6. Now we can manage it easily. We have 16 minus 11. That's 5. Our answer is 5/6. Now you know, this is why we need that common denominator first. We need to know if our numerator on the left is big enough to subtract the one on the right. If not, as in this example, then we use the whole number and make improper fractions. Then we subtract. I'll do one more example, and then it's your turn. The denominators are 10 and 5. The common denominator is going to be 10. To turn 5 into 10, I multiply by 2, so it's the same up top, and that's 8/10. You can see we can't handle the fractions separately from the wholes because we can't start with 3/10 and take 8/10 away. So we change these mixed numbers into improper fractions. 5 times 10, 50, plus 3 in the numerator, that's 53, over the denominator of 10, minus 2 times 10 is 20, plus the 8 in the numerator, that's 28 over 10. We want the difference between 53 and 28. You can do your subtraction working at the side, or you can use mental math. From 28 to 30, the difference is 2. Then from 30 to 50, it's another 20. 3 more gets us to 53. The difference is 25. Our answer is 25 over 10. And that's an improper fraction. Can't leave it like that. We have to change it back to a mixed number. How many 10s in 25? There's 2 10s in 20 and 5 left over. Keep the denominator of 10. The fraction part is 5/10. Look at that. We can simplify this fraction. There's 1 5 here, and in 10, there's 2 5s. That's 1/2. Our final answer is 2 1/2. Remember, for your final answer, you always have to show the fraction part in its simplest form, like I did here. And if you don't reduce your fraction at the end, you can't get full marks. Now it's time for you to practice for yourself. Next time, we'll look at part 1 of multiplying fractions.
We have this example.
Mister, can I go to the bathroom?
Okay. In this example, the question said estimate, then add, write the sum in the simplest form. Sorry, here we have wrong in the question. Then subtract. Write the sum or the difference in the simplest form. So the question here now, estimate, then subtract, write the difference in the simplest form. When you see estimate, must to do estimate at the first step, then do minus. As you see here, we have 5 and 1/7. The estimate of this fraction, 1 is very small comparing with the 7. So the estimate here will be 0. 5 plus 0 will be 5. Minus. Here we have 4 and 3/5. The estimate of this fraction, 3 is about of half of number 5. So I can estimate this fraction 1/2. So here will be 4 and 1/2. 4 and 1/2. When we have minus, we cannot subtract the whole number from the mixed number directly. We must to change the mixed number to the we must to change the whole number to the mixed number. How? As you see, as you know, 5 equal 4 plus 1. 5 equal 4 plus 1. And I can write 1 2/2 because 2/2 will be 1. So 5 equal 4 plus 2/2. 5 equal 4 plus 2/2. So I can write 4 and 2/2. So in this case, I changed from the whole number to the mixed number. Now I can do subtraction. How? 4 minus 4, 0. Now 2 minus 1 will be 1, and with the same denominator. So the answer here will be 1/2. See with me now this video.
Hey guys, I am going for a ride on my math wasp, but he is tired. He could use your help filling up his energy by doing some math. Today he wants to do subtraction problems with mixed numbers. Let's learn about subtraction with mixed numbers, then we can go for a ride. If you have learned about adding mixed numbers, then some of what we look at today may seem familiar, but if not, that is no problem, as we will go over the basics of mixed numbers. Here is an interesting problem. 2 3/5 minus 1 2/5. Do these numbers look funny to you? They are called mixed numbers. Do you know why? A mixed number is comprised of a whole number and a fractional number. Let's take a look at 2 3/5. The 2 means we have 2 whole units. This is the whole number. The 3/5 means we have part of a whole. This is the fraction. In the fraction 3/5, we have 3 parts of a whole that is split into 5 equal pieces. Now let's look at 1 2/5. In the mixed number 1 2/5, we have 1 whole and 2 parts of a whole out of 5 equal parts. See how the shaded regions represent both mixed numbers? We are asked to find the difference between these two numbers, which means we will subtract 1 2/5 from 2 3/5. I want to show you a strategy called takeaway, which is a fun way to subtract using our rectangular models. Okay, let's read the problem again. 2 3/5 minus 1 2/5. We can also say this as 2 3/5 take away 1 2/5. This means we want to start with 2 3/5. Now we want to take away 1 2/5. We can take away 1 whole first. Now that we've taken the 1 whole, how are we going to take away 2/5? Remember, 2/5 means 2 shaded parts out of the 5 equal parts, so we can take away 2 of the shaded parts of the rectangle. Great job! This is the difference, or how much we have left after we subtracted. We have 1 whole and 1/5, or 1 1/5. So the answer is 1 1/5. Great job, guys! Sometimes it's not easy to use pictures and figures to solve problems, so let's look at finding the difference with only the mixed numbers. Remember how we took away 1 whole from the 2 wholes? That's the same as 2 minus 1. And then we took away 2/5 from 3/5, and that's the same as writing 3/5 minus 2/5. After we did the subtraction with the whole numbers and then subtraction with the fractions, we added the whole number to the fractional part to get our mixed number. We show this in mathematics by using grouping symbols around the whole numbers and around the fractions. Notice the plus sign in the middle? That's because we added the 1 whole to 1/5 at the end. Great job! You did it without using pictures. I think you're ready to try another problem with me. Let's find 4 1/5 minus 2 4/5. Let's do this first using pictures. First, we will model 4 1/5. That means we have 4 holes shaded and 1 shaded part of 5 equal parts, or 1/5. Now we want to take away 2 4/5. That means we take away 2 holes, and then we need to take away 4 out of 5 shaded parts. Uh-oh, I only have 1 shaded part here. What are we going to do? I know, we can take one of the whole rectangles and partition or divide it into 5 equal parts. Now we can take away 4/5 by removing 4 shaded parts. How much is left over? 1 whole and 2/5. This means 4 1/5 minus 2 4/5 equals 1 2/5. And we can get rid of the empty rectangle since nothing is shaded. Fantastic! You did a great job modeling the problem, but what does it look like in written form? We started before by subtracting the whole numbers first, and then we tried to subtract the fractional parts. Remember, we can use grouping symbols to show the subtraction of the whole numbers and the fractional parts. We know 4 minus 2 is 2, but we got stuck when we needed to subtract 1/5 minus 4/5. Do you remember what we did with the rectangles? That's right, we turned 1 whole into 5/5, or 5 equally shaded parts. To write that by hand, we will split up the 2 into 1 plus 1. And then we will convert 1 into the fraction 5/5. Once we had the rectangle with 5 equal parts, Then we subtracted 4/5 from that rectangle. So we want to show 5/5 minus 4/5. We rearrange our problem to look like this. Okay, then we found 5/5 minus 4/5 was 1/5. And we finally combined the two leftover shaded parts. So we have 1 whole plus 1/5 plus 1/5 is 1 2/5. Wow, that was a lot of work. I wonder if there is another way to subtract mixed numbers. I know. How about converting them into improper fractions? Yeah, that will work. Let's try 8 1/6 minus 1 3/6. To subtract mixed numbers, we can convert each of them into an improper fraction. Now we need to know what an improper fraction is. An improper fraction is one where the numerator or top number is greater than the denominator or bottom number. Like 10/3 or 7/4. These are improper fractions. So how do we convert our mixed numbers into improper fractions? There's a quick trick to remember. First, multiply the denominator by the whole number. 6 times 8 is 48. Then add the numerator. 48 plus 1 is 49. Finally, write that value in the numerator of the improper fraction and keep the same denominator from the mixed number. We now have 49/6, which is an improper fraction. Great job! Now let's convert 1 3/6 into an improper fraction. First, we multiply the denominator by the whole number. 6 times 1, which gives us 6. Then we add the numerator. 6 plus 3 is 9. The improper fraction is 9/6. Okay, so we know that 8 1/6 minus 1 3/6 is the same as 49/6 minus 9/6. To subtract fractions with the same denominator, we subtract the numerators and leave the denominator. 49 minus 9 is 40. So we have 46. Notice both the numerator and denominator are even numbers, so the fraction can be simplified. The greatest common factor of both numbers is 2, so we can simplify it this way. We will go over simplifying fractions in another video if you have forgotten how to do that, so look for that video if you need it. Since our problem started as a mixed number, we should write it as a mixed number. To do that, we divide 20 by 3 to get the mixed number. 3 goes into 20 6 times, with 2 left over. This means 20/3 is equal to 6 2/3. Great job! We just used another method to solve subtraction of mixed numbers. You can use any of these methods we did today to help you solve the problems. Whoa! As you can see, the Math Wasp has tons of energy now. Whoa! See you next time. Goodbye. Hey, slow down. Hey guys, you have a few options here. If you want to subscribe, click the red button below. If you want to watch more awesome stuff, you can click.
مستر
اوكي
عندي سؤال.
تفضل.
في الفيديوهات حطوا ان شو اسمه مثلا الرقم اللي تحت 8 واللي فوق 16 وبعدين يوم ينقصوهم يطلعوا الناتج. هاي ينفع؟
When you want to subtract, very important to have the like fractions. If the number down the same denominators, you can directly do subtractions. Yes, no problem. Okay, but if you have the different denominators down, you cannot do directly subtraction. You must to change from unlike fractions to the like fractions. Okay. See with me this example. Subtract when right, then write the difference in the simplest form. We have here 12 and 7 over 6 minus 8 and 5 over 6. As you see here, we have the same denominator. Means we have the like fractions. So here directly I can do subtraction. How? Here I have mixed number and here I have mixed number. take the whole number here 12, then minus the whole number here 8. So I can write 12 minus 8. And here in the fractions, 7 minus 5, 7 minus 5 over the same denominator, over 6. Now 12 minus 8, 12 minus 8 will be 4. And here 7 minus 5, 7 minus 5 will be 2. Over 6, over 6. As you see here, we can change this form to the simplest form. Find the GCF between 2 and 6. Will be 2. So divide by 2 up and divide by 2 down. 2 divided by 2 will be 1 and 6 divided by 2 will be 3. So the answer will be 4 and 1 over 3. Example 3. Subtract, then write the difference in the simplest form. As you see here, we have 13 and 7 over 12 minus 8 and 5 over 12. Here we have the same denominator, so I can subtract directly. How? 13 minus 8 will be 5. 13 minus 8 will be 5. Then 7 minus 5 will be 2. Then put the same denominator, will be here 12. So as you see here, you can simplest form this form. 2 and 12. Find the GCF between 2 and 12. Will be 2. So here divide by 2 and here divide by 2. So 2 divided by 2 and 12 divided by 2 will be 6. So the answer will be 5 and 1 over 6. 5 and 1 over 6. Example 4. Subtract, then write the difference in the simplest form. As you see here, we have 8 and 4 over 9 minus 5 and 1 over 3. Look here to the denominators. Here we have 9, here we have 3. So the different denominators. So I cannot do minus directly. Must to change from unlike fractions to like fraction. How? Find LCD to the 3 and 9 will be 9. Now, which number times 3 will be 9? Which number times 3 will be 9? 3. So multiply the whole fraction here by 3. 1 times 3 and 3 times 3. Here no change in this mixed number. Drop the same mixed number here. Then we have minus the whole number here 5, the same. The change here in the fraction. So I can write here 1 times 3 and 3 times 3. Here drop the same mixed number, minus 5, 1 times 3 will be 3 and 3 times 3 will be 9. Now see, you have like fractions now. Now you can subtract. How? 8 minus 5 will be 3. Then 4 minus 3 will be 1. Then put the same denominator. So the answer will be 3 and 1 over 9. And here we have some videos. When you have free time, you can see these videos. And this is our lesson today. And now, who has question?
No one, mister, because that's so easy.
Mr. I do.
Okay, so what is our title today? What is the name of the lesson today?
Subtract and mixed fraction.
Great. We must do
Subtract mixed number. Then we must do revision.
Okay, subtract the mixed number. We must to compare between two cases here. If I have like fractions inside the mixed number, I can do subtract directly. If I have unlike fractions, here must to change to like fractions, then I can do subtraction. Okay, let us to take the attendance now.
Mr. The voice first.
Mister. Yes, mister.
Okay.
So can you do the girls first?
No, mister.
No, girls مرتين.
Yeah, mister.
بطي
نعم أستاذ موجود.
حارب.
أستاذ.
حمد علي.
نعم أستاذ. أستاذ اطلع.
يس. منصور علي.
موجود أستاذ.
اوكي. حمدان الكعبي. حمدان الكعبي.
أستاذ.
حمدان الكعبي.
هاي.
خالد.
نعم مستر.
اوكي.
أقدر أطلع؟
اطلع. دانيال.
يس.
اوكي. زايد. زايد الكعبي. زايد.
نعم.
أوكي. سعيد محمد.
نعم أستاذ. نعم.
اوكي. سلطان علي.
نعم أستاذ.
اوكي. سلطان غازي.
نعم.
سلطان غازي.
نعم.
سلطان غازي.
نعم.
موجود؟
أستاذ موجود.
اوكي. عامر الكعبي.
نعم أستاذ.
عبد الله الحمادي.
نعم أستاذ. أطلع.
يس. عبد الله الراشد.
نعم.
عبد الله الجابري.
نعم. نعم أستاذ.
يس. عبد الله الأحبابي. عبد الله مسعود.
نعم أستاذ.
عمر أشرف.
نعم أستاذ.
عمير الشامسي. عمر الشامسي. عمر الشامسي.
absent.
فلاح.
نعم.
مايد.
نعم. I can't leave.
محمد الحمادي.
ألو.
محمد سعيد. محمد سعيد السريحي. محمد سعيد. اوكي. مطاوع.
نعم
سيد.
أستاذ.
اوكي.
نعم.
معاذ.
أستاذ أنا موجود. محمد سهيل.
اوكي. معاذ.
يس.
أستاذ محمد سهيل موجود.
اوكي. All boys, you can leave, please. Okay, Asil.
Here, Mister.
Yazia.
Here, Mister. Sir, can I leave?
Yes. Jude.
Here, Mister. Here.
Rinat.
Mister. I am here, Mister. Mister محمد سعيد حاضر بس كان مايك خربان.
محمد سعيد. ايه اوكي. محمد سعيد السريحي.
ايه.
اوكي محمد. رينا روضة ناصر.
مستر يس روضة موجودة.
موجودة روضة. اوكي شمسة فيصل.
Here, Mr.
شيخ أحمد.
Yes.
شيخة بدر.
Here.
Here.
علي خالد.
No. Yes, Mr. Can I leave now?
لطيفة.
Okay, bye. Yes, Mr.
دين. دين.
مستر لين موجودة. Yes, Mr.
مروة. مروة.
Here.
مريم. مريم. مريم.
Yes, Mr.
موجودة مريم؟ اوكي. طيب مهرة فيصل.
Yes.
مو سعيد. مو سعيد.
نعم مستر.
أوكي.
نعم.
نغم. اوكي موزة. نغم.
نعم. Here, Mr.
يس. نورة.
نعم.
هاجر.
نعم مستر.
مهرة خلفان.
نعم مستر.
Thank you. So this is our lesson today. How to subtract the mixed numbers. Thank you for your listening.
Sir, I am here.
See you
Mister,
tomorrow.
I am Sheikh. I am here, but my mic was not working.
Okay. See you inshallah tomorrow. Assalamu alaikum wa rahmatullahi wa barakatuh.